Alright. Hello guys. So today we are going to go through and start the first series of what I hope will be a regular Twitch stream. So today what we're going to actually do is we're going to go through and make Pong. So Pong, pretty simple game. There's not a whole lot to it, but there's a lot of neat stuff that we can do with it that I think you guys will find pretty cool. Obviously, there's the multiplayer aspect. That's pretty simple, just mapping 2 extra keyboard keys and an extra paddle. Then there's also the AI, and I want to kind of go through and make a simple AI. It won't do a whole lot, but it'll kind of show you how AI in bigger games out there actually works. It's a pretty cool idea, and I think it'll be pretty cool. Sorry, checking for audio issues. Alright, false alarm, I guess, in the audio. So we are now going to go through and really quick we're going to set up some of the basic graphics and sound. This is kind of just a first thing I'd like to do to get rid of everything. So what we're going to do, and this is all going to be pretty simple, and in the future I'll try and have this done beforehand. That way you guys don't have to sit through and watch this, but it's a pretty cool thing to do. First off, I highly recommend looking into Inkscape. Inkscape is a free vector art program. It's really nice for being able to create art that's scalable, and especially nowadays, with a lot of cross-platform games, this is really helpful for taking your graphics and porting them from like a small screen on like the Nintendo 3DS to a large screen like on the like on a PC or an Xbox One or PlayStation 4. So what we're gonna do is we're just gonna draw a quick little circle. Might help to choose a color that is not white. And basically this is just the circle 2. We can bring it, put it there, and then scale it down to fit within our boundaries. And then go ahead and take that. And I've gone ahead and I've created a little folder for everything so far. It's just going to be the ball PNG file. And then what we'll do is we'll delete that. We will scale this down to let's say 32 by 64. And that will make it about as wide as our ball. Let's go ahead and further scale that. Make that 64, make that 128. So this is going to be a little bit of a bigger paddle. And then what we'll do is we'll come here. This is just the rectangle tool, and then up here we can make it have rounded corners. So we'll go ahead and make those radius of just 10, and we will put that there. The nice thing about Inkscape as well is that you can come in here and you can resize things with that tool. But then once you've selected a specific object or shape, what you can do is you can come down here and change the color of it by just clicking. So we're going to make one paddle red. We'll go ahead and just export that. We want to export the whole page, not just a part of it. And then we'll name this paddle 1. And then that'll be like the left side player, and then we'll come here and we'll make a blue one, and this will be paddle 2. Again, select to export to the whole page, and just rename that to paddle 2, export, done. So we have our basic graphics, so that's pretty much it there. We can close all of that. So now we have all of our graphics. So now that we have that, the last thing I want to show, and this has already been done, that's why I'm not going to worry too much about show you guys how I made it. I'll show you guys at the end if you really like the sounds, and all of these resources are going to be free to use. If you guys want to use them in other games, you're more than welcome to. Graphics maybe aren't as good. I like this sound though, so we'll go ahead and play this. And this is going to be the sound that'll play when the ball bounces. So you can kind of hear that, I think. So, and this will be all on GitHub. So we're going to go ahead actually now and open up GitHub. get that all ready to go. So, oops. And what we're going to do is we are going to name this ping. And this is just going to be a simple little clone of pong, effectively. So we'll go ahead and name that ping, get that all set up. It's going to ignore all the Visual Studio includes, is basically what that says there. That way things like, I don't know, files, like specific things we have to include for it won't be included online, like specifics to your computer, so like specific settings you might have set up for the project. This will help to keep things a little bit cleaner. So now that we've got our project, we've got that, we're going to go ahead and create the repository. And I got some kind of achievement. Interesting. And then we're going to go ahead and publish the repository, and the description is going to be publish. So that'll go ahead and publish that onto GitHub. And then let me go ahead and bring up a link as well so that you guys can go ahead and be able to see that on Twitch. So we'll go here, so there's that. And I will go ahead and put that down below. And that will be under the previous streams. It's going to be the very bottom one. So I will go ahead and put that down below. Oops. GitHub. So there's that. And a YouTube video of this will, of course, be up as well at some point. I just have to get it. But until then, keep an eye out for that. So that's all down there. You can go ahead and click that, and it'll open up the repo for you. So now that that is all done, let's go ahead now and actually create the Visual Studio project. So, new project, C++, empty app, and this is just going to be called ping. And there we go. So let's go ahead and put our main in here and just double check that everything got made correctly. So we're going to include the standard template library stdio stuff so we can display things into the console. We're going to create our main method that's just going to return 0. And what it's going to do is just do a simple hello world. And then it's going to enter an infinite loop so that we can actually read the text rather than it automatically closing. And as soon as it does that, we have our hello world. So our project is all set to go. So now what we're going to do is we are going to go take SFML. Before we do that, I'm going to go through and commit this. So added visuals dates, added Visual Studio project. Commit that, add that there. And then while that works, we're going to come here and grab our SFML download. If you don't have SFML already, you can go down this from sfml-dev.org. For those who are new to this, SFML is a simple and fast media library. And yep, I am going to use SFML again. A lot of the 2D stuff I'm going to use this for. It's just a really, really easygoing library. I have some other recommendations from last time. Right now I'm using stdio because I'm just more used to that, and I don't particularly like the IO stream stuff as much. It's a little bit lengthier to get set up. I mean, not by much, but you could. This is, for those curious as to what IO stream is versus what stdio is, it's basically a C++ specific for printing to the screen, whereas stdio works with C as well. So we can do hello world there, and then wall 1. And this will do the exact same thing, it's just, you know, different way of doing it. But yeah, we're going to do SFML because the reason we're going to use SFML is just, again, it's nice and easy to use, it's really simple to get set up, and I kind of have a thing for it right now. It's just fun to play with. The other thing is that we'll be able to do audio with it as well. It does all sorts of media rather than just graphics. We could probably use SDL. Maybe I'll do a future tutorial on that. But for today, we're just going to kind of stick with what I've been doing. So, this is how you would do it in pure C++. Again, what this is this isn't stream to the console output. So, C out. And what we're doing is we're saying that hello world is going to be stored into that console output stream effectively. That's not the super technical way to look at it, but it's a simple enough way. And the reason that we have this std : is that in C++ you have what's called a namespace. It's basically a collection of things under a specific header or idea, and it's a really nice way so that if you have two graphics APIs, both of them have window objects. One of them can be in one namespace while the other can be in another namespace, but they can have the same class names and you can still use them. It's pretty cool. I've used it a little bit. It's kind of hectic because then you get into all these different namespaces you have to remember and stuff, so I try not to do that too much, but it's pretty cool. The other thing you can do with this is we can actually, just some fun little C++ stuff real quick, is we can use cin and we can store this to an output. So what we'll do is we'll make a string variable test, and what we'll do then is we'll store our string output into test, and we'll do hello test. And I think we need to include string.h. And now if we come here, you'll see that it's waiting for something, so we'll type in Genesis, and it'll be hello Genesis. So C++ does have some nice benefits in that doing input is pretty easy, especially with the standard template library. Trying to do that in the stdio stuff is going to be a much bigger pain, so I won't even attempt to show how to do that because you have to worry about memory and all of that, but pretty cool stuff here. So let's go ahead now and get SFML included. So again, if you don't have SFML, just come to sfml.org or just Google it and go to download, and you can download it here. I've already gone ahead and done that, so we have everything we need here. So now what we're going to do is we're going to come here and we are going to set this up in Visual Studio. So we'll come into here, come into GitHub, and come into Ping, and we're going to right here make a folder called third-party libs. And this is basically just going to go through and house all of our different libraries. Specifically, it's going to hold, in this case, SFML. So we'll go through and we'll include these, and then we are going to come back out here, and we're going to go to actually we're going to stay in there, but we're going to come to our Visual Studio project. And what we need to do is we need to tell Visual Studio to use these libraries here. So the first thing we're going to do is we're going to right-click the Visual Studio project and click Properties, and that should bring up a window looking like this for you. If you go over here to Directories, then what we're going to do is we're going to have to tell it where our include files are for our headers and where our libraries files are. So this is pretty simple, it's not too bad. And again, if people want me to speed up with this kind of thing, you're welcome to just post in the chat and I'll speed everything up. But I want to make sure that everybody knows exactly what's going on for this first video especially. So what we're going to do, so when you start out with this, Visual Studio is actually looking in this folder, so we have to tell it to go up one folder, and then go into third-party libs, and then into include. So what we do is we say // to go up a folder, go into third-party libs, and then go to include. And there we go. Now we'll be telling it to look in here for any extra header files. Then we do the exact same thing, but for the lib path. So we're going to come here and do // third-party libs /lib. And the other thing I want to make sure I do is make sure that all of these libraries are just kind of tossed in there and not sitting elsewhere. So now Visual Studio is looking at those folders for our libraries. We now need to go into our linker and tell it to actually include the libraries that we want to use. So if we come in here and we edit it, it'll bring up a thing like this. And what we want to do is we want to basically just type in the libraries we need. So let's go into third-party libs, go to lib. The big ones we're going to want this time around are SFML audio, SFML graphics, SFML main, and SFML system lib, and SFML window. So we're just going to go through and include each of those. And I'm just going to copy and paste those. Also, make sure that you're using the debug, not the normal ones, because this is a debug project. It's going to be expecting it to have that -d at the end. So there's that, and so now we have all of our includes. These are the 5 main ones. So now that we have those all set, we're going to come down here and we're going to click apply, and then we're going to click OK. Now, normally what I do is I don't spend a whole lot of time going through and trying to go through and test it out by writing a from scratch program. So what I generally do is I just come into here and I take a window tutorial and I just copy and paste their code, because generally this is the easiest way to just get a quick test of everything going. So we'll go ahead and we'll run this, and you're going to notice that it's going to give you this error right here. Now the reason for this is that it can't find the DLLs. So what we need to do is we need to come out here and we need to copy in those DLLs. So going back to your SFML folder, you'll go into bin and you'll notice that there's all these different DLLs. So the big ones we're going to want are libsnd file -1, the audio, graphics, system, and window. And we're just going to come back to our folder for the project. We're going to go to ping and we're going to put them right in here. That way the project can see them. So now if we go back to our Visual Studio project and we launch it, we have our window. Now I'm going to go ahead and I'm going to upload this to GitHub so that you guys can get the latest version now. So this will all be synchronized on there in just a second, and you guys will be able to download a newer version of it. And for those who are going to be watching this on YouTube afterwards, this will all be in the description below. You'll be able to go through and click on this and see all the code as well. So we have all of that now. We have our basic window. So now what we're going to do is we are going to go through and make the basic game state manager. Now I've done this several times before. This is going to kind of be the last time that I go over how to make this. And in future projects we're just going to kind of copy and paste this. That way we don't have to spend as much time on it. But since today's is going to be a pretty simple game, we're going to go through and do it. We're going to name this game state, and it's going to be a header file. And we're going to put in hashtag pragma once. Basically this says that this description should only be created once in every file it's included in. Now we're going to come in here and we're going to include SFML, and we're going to include the graphics.hpp file. This is basically a header file that tells us what all of the graphics functions are. Then we're going to come here and we're going to create a class that's called tiny state. And tiny state is basically going to be what actually is being called when we go to different game states. So the way to think of a game state is main menu, your multiplayer match, your single player match, your options screen. All of those are different states at the end, and so this is going to be what manages it. So let's go ahead now, and we need our initialize function, and this is going to take in what's called a render window. And it's going to make sure to be a reference to it. And what we can do is we're going to use some fancy stuff now. And so that will make sure that this is a reference to the window instead. And we're going to do virtual void update. And this is going to basically just update the game state. And virtual void render for rendering the window. Virtual void destroy. And so now we have all of that, and we're going to come down here and we're going to actually make our game state class. And this is going to have some public stuff and it's going to have some private stuff. Basically, public is visible to everyone, and private is only visible within this class. So within this class, we want a tiny state object. And this is going to be our actual state. And up here, we're going to have a empty default constructor. And then we're going to have a void set state. Just going to take in a tiny state object. And this is actually going to be a reference, however, instead of a cloned object. The reason for this, it's going to actually be like a pointer to the state instead of just a reference like normal. And the reason for this is that we want to make sure that we want to basically make sure that we are creating the states as new references and such instead. So let's go through now, and we have our tiny state and stuff, and we're going to make sure that's a reference as well. And within this, it's just going to set this state is equal to state. Now the reason for this, the reason for the use of this state instead is that we want to make sure that we're referencing, this is going to actually be referencing this state specifically, whereas this one is going to be referencing that one. So, once we go through and do that, what we'll want to do as well is we'll want to also make sure that if the current state is not null, sorry for my distraction, I'm looking at the chat and seeing what's going on in here. So, we go through and we say if the state is not null, then this state destroy. So we want to go through and destroy the previous state. And what we're going to do is going to destroy this window. And this is just also going to have a reference to a window. And then we are going to come up here, and this is going to have a void set window method. And this will basically say if there's a previous state, destroy the current state, then reset the current state, and then finally do the exact same thing if it's not null. Then this state initialize. And that will go through and make sure that we initialize the window. So, once we do that, we have two more things we need to do. We need to come here and do an update method, which is basically going to call the state's update method. And we only want to do this, though, if the state is not null. And one last thing that we'll go ahead and do is we want to make sure that this that the state is definitely null. Because you never know what it could actually be when it's initialized from memory, because it's a pointer in this case. So we want to make sure that we go through and we double check that. So we make sure we call our render and we render the window. And then of course the last thing we need is we need, when the game state is destroyed, we need to make sure that we destroy the states as well. And this will go through and make sure all of our cleanup is done. And so, yeah, there's everything that we need for our basic game state. So now what we're going to do is we're going to give this a quick little test run. We're going to add in a test state header file and a test state source file. And this is basically going to need to, again, have the pragma once. We're going to include GameState.h. We're going to do class test state public tiny state. And this is basically to make sure that the they have the same accessibility within each other. Long story short, because this is public, we need to make sure that over here we have this be public. And then we come here and we just recreate those. And this time around, though, it's just going to look like this. I'm going to copy these, render. And there's that. And so there's our 4 methods we need. Come here and include test state.h. We're going to have void test state. And then we can initialize window. And come here and copy these again. Destroy. And we're just going to do, what we'll do is we'll actually go ahead and we'll use the IO streams and stuff. Include IO stream. We'll make it a little bit more in depth than normal. So we'll come here and we'll do cout nit'd and cout destroyed. Now we need to come over to our game state. We need to make sure we make a core state. Now this is going to be the main state that is used. So it's going to be external core state. And we're going to come up to here. I'm going to put in here include game state. And we need to go through and change this to a render window. And we'll define our core state again to make sure it's used. And rename this window to ing. Keep it at that size. Set window to window. And this can all pretty much stay the same. The big things we need to add in here are core state update. So, few quick questions on here. We have, what if you want to add a pause state? Your state manager would destroy the game state in order to switch to the pause state. State would be much better to keep track of your current state. Stack would be much better to keep track of your current states. So the reason that I am going through and not doing a, the way that you would actually do a pause state is a little bit easier actually. So we could add into this the option to do a pause state. The way that you would want to do that is you would effectively want to have a pause loop and a normal update loop. The only problem with that is not everything has a pause state. Multiplayer should never have a pause state that will pause the entire game. It should only pause partial things. The other thing is you also want to make sure that you have whatchamacallit, that on like the main menu that you, again, you don't really need a pause on a main menu. So what you can normally do in that is you would have that be specific to that state. So let's go ahead and we'll just show how to do that. So we'll have a bool pause variable. And by default, of course, this would be set to false. And then you would have somewhere in here, you would have an if pause, then do, you know, normal game here, and else you would have paused game here. And the idea is that you could do that for both your update loop and your rendered loop. This would basically allow you to have a pause state in both of these. You could effectively use a stack to keep track of your states, but again, that's going to be a little wonky to do. It's a little bit overkill for structure-wise. This is a very flexible system, and also it allows things to be much more isolated from each other. A stack will kind of link things together still. You could, in theory, it's not too bad. As for this, is this a rebroadcast? Didn't you do this already? Again, like I stated before, I've done this a few times now. The reason I'm going through and doing this is for new viewers, anybody who didn't see the previous broadcast, as well as to make sure that this is more formalized, as this is like the first official stream, with the previous ones being more to test things. Future streams, I will not be redoing this. It'll be done and over, and we'll just kind of copy and paste the code just to make things easier, because we won't want to reuse this. But that's a quick way that you can do a pause state, and then of course in here you can set this paused equal to true, and you know, false down here and everything. So we can go ahead and we can do that in the main game, but for now we're just going to leave that alone. So we need to make sure that we update the core state, and then we render it as well. And of course, coming down here, we don't need to destroy it because that will actually be automatically handled by cleanup when the game is being destroyed. So now that we have all of that, let's go ahead and give this a test run. So we'll come here, and we'll include, thank you, test state, set state 2, and we're going to make sure, now you'll notice that I'm going through and I'm using the new here. The reason we're using new is that makes sure that it's a reference to it. This is kind of important because we need to make sure that this is a reference and not a normal object in order to make sure that the cleanup and stuff works better. So now if we go through and we run it, we'll see that we get a few errors. Now where is this coming from? So we can't do that with SF. Basically, this is non-copyable, so we can't do that. We're going to have to use a reference. So what we'll come here and we'll do, and this is a pretty simple fix, we just change all of these from ands to stars. And the reason for this is just that SFML apparently has a thing about not letting you use, whatchamacallit, you cannot use them because they need to be private, or they need to be public, but they're kept private within SFML's libraries. You could go through and modify SFML to fix that, but no point. What would happen without new? So the way to think about it is that in C++, there are two types of things going on. You have two ways that you can access objects. You can access them as a reference, or you can access them as the actual object. So the whole thing with this is that basically, so without new, let's do it this way. So we have our tiny state object, state, and we have two ways that we have one way we can initialize this. We can just do tiny state like that, and that will create our state. Now you'll notice though that there's no star pointer reference or anything. Basically what this is a new instance of state. And of course we can go through and we can create a second state, and we'll call it state 2, and it's that. Now if we want to set state 2 equal to this state, the way that we would do that is we would set it that way. But if I change something in state 2, actually, let's go through and do a quick little pointer on tutorial on pointers. So what we're going to do is we're just going to pause this for a quick second, and we're going to show this. So we're going to have a pointer that'll be int num1, which is equal to 5. We're going to have int num2, which is equal to num1. Now, let's go ahead and we will print out num1, and then we will do the same thing to num2. And we'll add on the wall 1 there to make sure that we don't go past this. And finally, include IOStream. Yeah, technically pointers and references are different. There's some, it's kind of tough to explain. I'm not going to go into that right now. I'm basically using them interchangeably. They aren't know that, reference that. There are differences, however, pointers can be kind of used like references. So real quick, let's go through with this. Let's show exactly what pointers and everything are. So the way to think of pointers is that you're pointing to an object rather than actually having the object. So right now you'll notice we have num2 is equal to num1. So when we go through and when we run this, what you'll notice is that it will print out, whoops, let's make sure that we print out a new line. So let's go through, and I'll explain that in a sec, a little bit better, references versus pointers. But you'll notice we printed out, it says 5 and 5. Now if we go through and we change num2 is equal to 7, for example, okay? What we would expect is num1 to be 5, num2 to be 7. If we run it, that's exactly what we get. Num1 is 5, num2 is 7. So if we go through now and we make this a pointer instead, and we reference that by making this and num, then what we have to do is if we change this to 7, we're no longer changing just num2. We're actually going to be changing both num2 and then, whoops, we also need to print it out by doing the star here. Now if we go through and we change num2 to 7, you'll notice that num1 also gets changed. That's because num2 isn't actually storing a value of 5, it's pointing to num1 now. And because we're changing the value of num2, we're also changing the value of num1. So that's kind of what that means. Now when it comes to references, that's usually with how you pass things into methods. So if we come here and we have a, I don't know, let's go through and we'll have just print out our num1. And what we're going to do is we're going to have a method that add 5, which basically will take in a number and it will add 5 to it. Now if we go through and we call this add 5 to num1, we go through and run it, basically we still get 5, we don't get 10. And the reason for that is that num1 is passed into here, but it's not passing it as a reference, it's just passing the value 5 in. 5 gets added onto that 5, and then nothing happens, because when we come out of here, num1 is still the same. But if we come in here and we add that little and sign, in this case, when we go through and we run it, it will add in that, it'll not pass in the value 5, it'll actually pass in num1 as a reference. It's referencing this num1. And it'll add 5 onto num1, so that we printed out here, we now get 10. Yeah, there's a lot more going on with the heap and stack when it comes to new. I'm not going to go into all of that. This is just kind of a brief overview of pointers and references and things of that nature. And yeah, there's a lot of corrections on here. There's a lot more to this, but this is kind of the basic gist. This is why you'll see me differentiate a lot between pointers and non-pointers. I tried to figure out a way to get references in there, but SFML is causing a little bit of a headache with that, so I'm not really going to try much more. But this is kind of a quick overview of pointers versus references versus non-pointers and such, and what kind of the differences are. There's a lot more to it, but long story short, this new basically allocates the memory for a new test state and then uses it as a pointer to that memory space where we can then use that object. And so it creates a reference to it rather than a whole new object. So it's effectively the int star rather than int. Yeah, you can. Yeah, you can use pointers to reference to point to both. So, but either way, this is just kind of why that new is needed, because in our set state method, we're asking for a pointer to the state rather than a state object, and so that way we'll be able to manipulate that specific state without going through and constantly creating new ones each time. So let's go ahead now and run this, make sure that that's all working. And if we come over here, you'll see that it's been init'd properly, and that's all set to go. So now we have our basic game state. This means we can go through and create a little main menu. So one thing I forgot to do graphics-wise is we need a free fonts. Let's go to 1001 fonts, and I don't think that is going to be okay. Personal use, public domain, here we go. We'll use dancing, let's see here. Anything good that is free for donationware, free for personal use, Is there any way to sort these? Guess not. So what we'll do is we'll just come down here and we will use the, where was it? Did it just get pushed away? Here we are, public domain, dancing script. So this will be included in the project because it's public domain. I'm trying to make sure I'm cautious with that. So let's go ahead now and bring this up. And so this is just going to be a font that we'll be able to use for the project. So we'll just include the regular one. Come over here to our GitHub thing, and we're going to put that right in here. And I'm going to just name that font.ttf. Excuse me. So now that we have our font, let's go ahead and we will rename this to our main menu. And this is just going to be a little menu that we'll be able to use for everything. So let's go through, and we need a few different things. We need a font reference here, and we need a text reference there. And this is just going to be our title, and then we're also going to have, actually I don't think those need to be references, do they? I don't think so. And we'll keep them that way. And we'll leave them like that. Okay. And actually, that's right, we need to have, what was it? This, and we will have yeah, we should probably go through and have a destroy into it. And come down here and do delete state. So the delete basically goes through and deletes the basically this is how you delete things when you have them as pointers using new in C++. So if you're using new, you need delete. and that will come through there and call that. So let's come here, main menu, and 2, 3, 4. That super do. Guess not. Oh well. There we go. So that'll make sure that's destroyed. And then this will be where we can destroy the rest of our objects. So, it might be better actually. Sorry, I'm kind of going through and seeing how to best organize this, since this is going to be used for future projects quite often. And what we'll want to actually do is just destroy those there. So that'll make sure our fonts and text are destroyed. Again, we have to dereference it there, and we'll make this 188U. Load from file, and this is where we're going to load that font.ttf file that we downloaded earlier. And in the render, we're going to have window, draw, and that'll draw this. And then the last thing that we have to do is window clear, and we're going to clear this to color. Make sure that's just black. Window display. Make sure it's actually drawn, and there we go. There's our little text. So let's come back to the main menu. We're going to set the font to be in the center, so we need to set the origin of it. And this is basically the where the corner of it is. So normally the top left-hand corner is where you draw things from starting, and so we're going to set that to be the center of it. So this title, get bounds, width over 2, this title, get global bounds dot height over 2, this title, set position to window, get size x over 2, this window, get size over 4 maybe. Let's see how that looks. Yeah, that looks good. Right there in the center. Our fancy pong clone. So now we have that all set, and the final two things we'll want are the ability to do have a play and quit button. And again, this is a lot of just rehashing what we've done before. I'm just kind of going through and doing this so that we have it all ready for future projects. And to make sure that everybody knows what's going on. So we have our play, quit, play, quit, start. And this is going to be play. And we can probably set this to 256 U even. Leave that out for now. And that's a little bit too big, so we're going to do those. We're actually, instead of shrinking things, we're going to make this a little bit further up. We'll actually change that to 1/6 of the height. So there's that. We'll bring it up a little bit more, and honestly, we probably want that at the top to begin with. So what we're going to do is we are just going to bring it down by half of its height so that it's not cut off at the top. So again, just do that. That's a little not quite right, so what we want to do though is we want to just do that. And that's still not quite right. So what we'll do is we'll do 1/8 of the window size and see how that looks. That's better. And then we will go through and change that to 1/3. Oops, that's going to go smaller. That'll be fine. So we have that, and we're going to do the exact same thing for the quit button. This time, add on to the height from before so that it stays, so it looks okay. So I should say quit, and quit there. And we have our play and quit buttons right there. So now that those are all done, let's go ahead and have them look a little bit fancier. So what we're going to do is we're going to make them let's see, how do we want to do this? We'll go ahead and we'll have the selected one just be a different color. So we have a selected value which basically says which item is selected. By default, we'll set it so that the play button is selected. And the way that we do that is we do switch this selected. Now the reason I'm using all of these this all the time is to make sure you know where the references are coming from. This will kind of help keep the code a little bit more clear so that you know, like, window in this case is coming from within this method, whereas quit is coming from the class. So it's really just to keep things a little bit clearer. Make it look a little nicer. So I'm going to set the color to SF color white by default, and then depending on the state, we will change that. And in this case, we'll set play, set color to SF color green, and otherwise we'll set quit. And so because play is selected, it'll select that one. And then finally what we want to do is we want to come down here and we're going to have bool up key and bool down key. Now SFML has built-in event stuff so that we could do this using their events. However, then we have to actually tie it all into our then we actually have to tie it up to into our game state management, and it gets really chaotic. So I generally find it easier to just add in basically a Boolean check for keys. Key, and we'll do up, and this will basically let us double check whether the previous state was, whether the previous key, oops, that's why, whether the key was previously pushed or not. So down, and if SF keyboard is key press, SF keyboard key up, and not this up key. And so basically that says if the key is up is being pressed now and it wasn't being pressed before, then do something. So we'll do this, selected minus equals 1, and we'll do the exact same thing but for the down key. In this case it'll be +1. And then if this selected is greater than 1, then it should just reset to 0, because we're going to scroll through. And if it's less than 0, then it should be 1. So now we can come here, we can select any option we want. And so we're able to go through and do that. So now that we have that, let's go through and add a global variable that determines whether to quit the game. So we're going to have extern bool quit game. And this is by default going to be set to false. That way it doesn't automatically quit out. And then what it will do is it will be put in right here, if quit game, then window close, and this needs to be put, however, at the very, very end here after the window is displayed one last frame, because if we close the window there, then it'll cause all sorts of issues for these two methods as they try and use the window. So let's go ahead now, and now that that's all done, we can go into our main menu, and what we can do is we can check for if SF keyboard is key pressed, SF keyboard key enter. And that is actually supposed to be turn. Then we're just going to switch through our options. This selected, case 0, we'll go to a new section of the game to play it. And if it's 1, then we want to set quit game to true. That way we can go through and exit the game. So now if we come over to here, you can see the game running. We can go through and select our options. Play does nothing, but if we do quit, it goes through and quits the game. So we have our basic main menu all set to go. So let's go through now and get that going. So we're going to go through and create a new item again. This time it's going to be another header file, and it's going to be main game. And we're going to go through and we're going to do new item, main game for the source file. Again, pragma once to make sure that it's not included more than once. We're going to include gamestate.h. We're also going to want to make sure we include the main menu, because we're probably going to want to make sure the players can go back to that. And then we're going to include main game.h, and actually this can be included, however, in here instead, because we're not going to need it in the header file, because this is just going to declare the class. So I'm going to go through and I'm going to be kind of lazy, and I'm just going to copy this entire thing just to make lives easier. And I'm going to rename this to main game. Game, that can actually be removed. And we can actually come here and remove that too. So I think we got rid of that, right? Yeah, cool. So there's all that. So the font that I am using right now is, right? No, that wasn't it. This one, Dancing Script. So this is free public domain. It's, pretty simple looking font. What I'm going to do as well is I'm going to go through and update the GitHub repo. Added the game state. Added a simple public domain font, and I'm going to put a link in there to whoever created this. So if they ever watch this, thank you for your awesome font. And so we have our font, we have our game state, updated main to use the game state, added a simple main menu, and that is it. So we'll go through and synchronize this. So this will all be on the GitHub now, so you guys can download that. And what I'm also going to do now is I'm going to go through and do a few other things to make this a little better. So right now, everything's just kind of tossed around in here. I generally don't like that. I like to add some nice filters. So we're going to have a core section, which is for core portions of the game. Game that would include that. We're going to add another filter for states. So we're going to add states, and this will include these two. We're going to come here and we're going to do the same thing. This is going to have a states though, because most of our core stuff will be just header files that we can go through and easily include. So we have our main game here. We don't really need any of this. And then we can come into here and we can copy most of this. We just need to get rid of some of it. So all of this can be destroyed. This all can be removed. This can be removed, and this can be removed. And now we need to make sure we rename this to main game. And finally, let's come back here and make sure we remove, because I nearly forgot to remove this. Play, delete this, quit. So that'll make sure that our resources are freed. Well, not freed, but cleaned up. And so now what we want to do is we'll want to make sure that we say if SF keyboard is key press SF keyboard key escape. And what we're going to do is we're going to take our core state and we're going to set the state to a new main menu state. And we're going to come over here, and this will go through and delete all of that, and we're going to come here, and we're going to do the exact same thing, but for the main menu, and it's going to go to the main game. We need to come up here and make sure we include that. So now if we go through and we run this, you can see that we can go through and select that, and if we go back, it'll come out to here. Now, one thing I do want to bring up, I still haven't filed the bug for this, but you'll notice that as we switch between, we have our task right here. And right now, the memory being used is about, it's about 26.7 megabytes. But as we come in and out of this, it should, no, it's not doing it this time around. I guess it's been fixed, or I did something differently. Never mind then, I guess that's gone. Well, that is all set. So we have all of our fonts and stuff. And so yeah, so I will go ahead and commit these changes one more time. So the reason that we went through and used all those game states to kind of highlight this a bit more is you notice we can go through and we can create this from a tiny state. We give it 4 basic methods, and then we can focus entirely on this. And then we make sure we clean up our resources so that when we're done, we don't have to worry about it anymore. We can go ahead and close both of those because our main menu is done. Our game state right here is not going to depend on it that much outside of just going to it, which again, this is all self-managing, so we don't have to worry about it, you know, we don't need to worry about the main game freeing resources from the main menu or anything weird like that. It's a simple state to and from, and so it makes it really easy to go through and manage this. So now that we have this done, what we want to do is we want to go through and configure this to be able to actually have our game. So a few quick things we'll want to do. First off, we will want to go through and create our main characters. So there's only really going to be three things that are needed. We need to create a simple entity that can be rendered. we need to make sure that we are able to check for collisions between entities, and then we need to be able to move some of those entities around. So we're going to go back to our core section here. We're going to add in a entity class. And this is basically just going to be things in the game. We're not going to make an entity manager this time around. Again, that's a little bit more than we really need for this. This will allow us to keep everything simple. /graphics.hpp. And what this is going to do is it's just going to be an entity. And it's going to extend the SF sprite class. This will let us to be able to render it directly with the window object, rather than having to go through and pass in the window object and then render it from in there using that window object. You'll kind of see more about what exactly this is going to let us do. It'll be a little bit easier to use as a result. So we need a public and a private section. And in the public section, we're going to have our entity base class. And that is not really going to do anything. And then in the private, we need to make sure we have a reference to a texture. And this is basically going to be the actual graphic that is used for this object. And what we can do is we can then come into here and we can say void load. And this is basically going to take in a string file name. And it's basically just going to load in this textures. It's just going to load in the image file that we desire. So what we need to do now is we need to come over to our project. We have ping there, and we have we need to come into here, and we need to get the graphics. So let's come over here into documents. We have tutorials, ping, we have our ball, our paddle, and our paddle. We're going to come in here and just paste those into there. So we have those. And what we're going to do to keep this a little bit more organized is we're going to come into here, we're going to create a folder called graphics. And this is going to have our paddle, and it's also going to have our font. And we need to come into our main menu real quick and adjust the font's directory. So graphics / and if you wanted to, you could go through and make subdirectories for everything. I'm not really going to worry about that all that much. So we have our graphics folder, and this is basically going to be where we can put all of our different graphics for things. And then we're going to come over to our entity, and this is all going to be again loaded from there. What we're going to do is we are going to make this a little bit more organized. We're going to have a sprites folder, and that is going to house our paddle and ball. And so what we can now do is we can say to look in the graphics / sprites folder for our file name. That way we can just house it in a file name rather than having to give it this whole long directory every time. So now that we have that, we need to go through and make sure that this is set to use the texture. So we set texture from here, and we tell it to load this texture. And we also need to make sure here that when we create the entity, that the texture is set up again with the new SFX texture. So we have that. And finally, what we want to make sure we do is that when this is destroyed, we delete this texture.
Call from 817492144.
No idea who that is.
Call from 817492144.
So no. Okay, so this will go through and automatically delete our textures and stuff. And this will also go through and create it. And we have our load method to actually load from a specific file name. So now we are all ready to render a quick test guide. So we need to come up here and we need to include entity.h. And we'll go through and we'll just load our paddle. So we'll have entity paddle. And again, we're going to make sure we reference this so we can go through and manage everything a little bit better later. And down here we need to make sure we delete it. And in our initialize function, we'll have paddle is equal to new entity. And make sure we specify where that is. And then this paddle load, and we're going to load up paddle1.png. And now the nice thing is that we can just render this again by doing window draw this paddle. And now if we go and we run this, get one error. And the reason for that is what? Again, this needs to be public so that all of its methods are properly accessible. Now if we come here and we run this, we have our nice little paddle drawn up there. No, in this case it's this is a forward slash, this is a backslash. That's how you do escape characters. That's why that works. Yeah, C# is I think the weird one with that, yeah. So now we can go through and we can draw those. Now next what we're going to do, we have our chord there. We're going to now add a entities filter. And this is not going to have an entity manager, but it is going to allow us to do some nicer things. So what we want to do is we want to have our paddle1 and paddle player. And what we're going to do is we are going to do pragma once. We're going to include the entity class. And we're going to do class paddle player public entity. And again, this is just going to have some nice little things we'll be able to use. Excuse me. And what we'll be able to do now is to go through and set it up to be controlled from there. So what we want to do is each entity, really we don't need a whole lot from this, but what I am going to do is I'm going to add in velocities. So we're going to have SF vector 2F, and this is going to be velocity, which will tell how to move. And we're going to go through and we're going to have an update method. And this update method is simply going to move the object based on its velocity. And so all we have to do now is change the velocity to get it to move. So what we can do is we can come into our paddle player here. And the nice thing about this, one more thing we'll want for each entity is a collision method. So we're going to have bool collision, check collision, and we're going to just pass it in another entity reference. And what it'll do is it'll return if this global bounds intersects with entity get global bounds. And if those intersect, it'll return true, saying that there was a collision. So now what we can do is we can go here, and in here we want a public area, and what we're going to do is we need to come up here and make sure that we make this method here virtual, so that we can override it in here, where we will then do void update, and we want to make sure that we call the super version of it. Basically what this will do is it'll make sure that this paddle calls the update method from here, making sure that everything moves. So the next thing that we want to do, we're going to set this velocity, and is that, that's private. We want that actually under protected. And protected will basically let subclasses see it. X is equal to SF. And we only want to update the Y in this case, so we're going to set SF keyboard is key pressed, SF keyboard key up. Oops. Yeah, down actually. Minus SF keyboard is key pressed, SF keyboard key up. Now this is kind of a bit of cool math that we'll be able to do. So what we're going to do real quick before we do anything else is we're going to make sure that when this entity is created, that the texture that is set up is the paddles texture. That way we don't have to set it to be loaded each time. So we're going to have paddle player, and this is going to make sure to call the super. So that'll already be done. And then we have this load, and it's going to be paddle. Well, we actually don't want to do that quite yet, and I will show you why. Well, I guess we can just go to do it. And we're going to have a private variable that is int player number. And we're going to set that player number here. And then we're going to switch through and player number, case 0 for the first player, and case 1 for the second player. And then what we can actually do is we'll just have player, we'll have it be so that player 1 is that, and player 2 is anything else. And this load, and I think we named it, yep, paddle 1 and paddle 2. And what we're going to do here is we're going to switch the player number again, because each player will have different keyboard controls. So case 0 for player 1, and then default will be for any other player. And the other player is going to be up, down, but the player 1 is going to be W and S. So S and W. That'll go through and handle players and everything. So now what we can do is we can come to our main game, and we want to include paddle player, paddle, and if we come here and we run this, it'll give us an error, and that's because we need to make sure we do that. And we're going to set that to player 0, and we also need to make sure that we call this update, whoops, paddle update. And you'll notice that that's very, very fast. So what we want to do now is we are going to want to set that to a percentage. But before we do that, what I'm actually going to do is I'm going to slow down the game a bit. This is because, long story short, when you do a game and you have an infinite loop like that, it actually is not good to do that, because you're basically going to use like 100% of the CPU to have such a thing happen. And there's other ways you could do it. You could do the synchronized stuff in there. I'm just going to do this because it's a little bit easier to use the sleep method. And if you don't have a powerful PC, vertical syncs and all of that can be really, really detrimental to your computer speed. So sleep is generally just an easy, quick way to go through and do it and not have to worry about it. I know SFML has some other built-in stuff, and I think I've used it before, but I can't remember specifically. So we have our paddle able to go up and down, and when we go through and do this, this triggers a breakpoint because we have deleted something. So what we need to do is we need to actually go through and make sure that this is the last thing called, because after this gets called, it deletes this current state, which destroys the paddle. So we don't want to have that happen. Try and render the paddle after we've destroyed everything. So we'll go through and we'll do that. Now if we go back, it all works. So we have our first paddle there. Now what we're going to do is we're going to do another paddle for player 2. So we're going to have player 1, and we're going to have player 2. And we'll come here, name that to player 1. And then come here and do the same stuff for player 2. And now we will have player 1 and 2. And what you'll notice is that they're right now on the same side of each other. So what we're going to do is we're going to make sure that when the player paddle 2 is loaded, that we also set the position over a bit. And we're not going to do that there though. Well, we could, but we're just going to do it here because you never know where you might want to move players later on. It might be you want to change their positions later on. So set position, and this is just going to be window get size x minus this player 2 get global bounds width, and that'll put it right on the edge, and then we'll set that to 0 because we don't want to change the y. So now if we come in and we play, we have our 2 players all ready to go. And they're able to be independently controlled. And yeah. So there's our paddles, and now what we need to do is we need to get it so that we have the ball object. So let's go ahead real quick, and what we'll do one last thing is we will make sure that the paddles cannot be colliding with the edge of it. So we have our update to move it, and then we will do if this get position y is less than 0, and this move 0 and 0.1f to move it smoothly, and we're going to do the same thing for if it reaches the edge. So plus this get global bounds height is greater than, and in this case it's going to be the window height, which is I believe 600. Then we want to move it up a little bit. Now normally you shouldn't use static numbers. I'm doing that in this case just because I'm a little lazy. So go through and do this. And now if we try and move further up, oops, didn't quite work, did it? Let's see what's going on here. So let's see if this is ever triggered. And it is, but it doesn't seem to work properly. And the reason for that is that we're moving too little. So what we'll want to do is we'll actually just want to go through and move it at the same speed instead of being all fancy. So now we have it so that it can't collide with the top or bottom. And ta-da! So now we have our paddles all set. The last thing we need to do is we need to add in a ball. So we'll come here, we'll make a ball. And again, we're just going to go through and copy most of this. Now the big thing with this is that we are not going to want to include, we're going to want to kind of split this up because otherwise it's going to get very messy very quick. So what we're going to do is we're going to come down here and add in a new filter for entities. And we're going to add in a new item. We're going to add in our players, our paddle player. And we're going to add in the ball one. And the reason for this is that we're going to be referencing between these again. So we need to make sure that, long story short, that all of our classes don't conflict with each other by including multiple headers and stuff. So we're going to include paddle player, come here, and then paddle player. Update. And then we need to get that. So there's that. And come here. Player.h and rename this to ball. And then again, ball. We don't need that, but what we do need is we do need to make sure we reference the paddles. So what we're going to do is we're going to have paddle player, and this is actually going to be, well, yeah, we'll go ahead with this. Paddle player, player 1, paddle player, player 2. That way we can go through and be able to check collisions within them. And we need to make sure that we set that up in there, so that as soon as it's created, player 1 will give it to them. So we have that. We'll come here, and we just want to include those two methods, include all.h. Then when we do if this check collision with this player 1, then this velocity x times equals -1. And we do the same thing with player 2. And then what this will do is it will make sure to bounce it off of the players. Here, do that. And the final thing we need to do now is we need to set this at the center of the screen. So this set position, and I'll set position to, and we can actually just do that. We create the object. So we have all of that, and we have if this position x y is less than 0, then this velocity y equals -1. Or if the y plus this get global bounds dot height is greater than 600. Again, I wouldn't normally do that, but in this case I'm going to, just because it'll be easier for right now for me to do that rather than making some system where we pass in the window and everything. So now that we have all of that done, we can go ahead and try and create it and see how that goes. So we need to include the ball, and we'll come here again, ball object, and right here is where we'll create it. New ball, and we need to include this player 1, this player 2, this play ball object set position 2, and we want to do window get size x over 2, this window get size y over 2, and that'll set the ball to the middle of the screen. And the last thing we need to do is we need to draw it. And this time we didn't draw because we also need to give it the graphic. So this load ball.png. There's our ball, And then to make it move, we just come in here and we say ball.update. Oops. So now that's able to draw, and it's able to move off of the paddles. And if it goes past right now, it's just going to kind of vanish. So what we're going to do now is we are going to also set the ball to have a y velocity. So this velocity y is equal to 0f. And we'll go ahead and we'll update the ball to be faster. Here. And you'll notice that when it goes through like that, it doesn't bounce off properly. So what we need to do, we could go through and we could add that. But what I'm going to do instead is I'm actually going to have it so that if it goes less than that, it's just automatically going to be counted as a loss for the player. So what we're going to do now is we are going to have a point system. Or maybe, how do we want to do this? Yeah, I guess we could just add a score object and keep things simple. New item. Score. Magma once. And then we're going to this time include SFML/graphics.hpp. And it's going to be class score, which extends SFML public SF text public private. We're going to have SF font times font. Actually, we don't even need that, because what we can do is we can just set it up to have its default constructor. So we can do, how do we want to do that? Oh man, let's do this. Render all set to go. That only needs to be incremented when the player scores. And what else do we need? I think that's it. Here, new item, score, score, and then score. And then finally, we want to have an update. And what this is going to do is it's just going to update the drawing on the score. Void delete. String to score. SSTD. And it will be this value. Now we'll go through and update that with the score string. And finally, we will want and so we have this new SF text stuff there. So we're going to want to do score do that. And finally, let's get, what is the type for that? Unsigned integer. And what we can also do with this instead there's that, save us some memory. That'll automatically update the score. Main game. We'll include the score object now. That'll be for player 1. This couldn't be drawn. Because we have to come into the score here. We have to make sure that we set. So that should be equal to new score. Let's double check that's working. Font is not being set properly. File. Score. There we go. So the final thing we need to do is set this value is equal to 0. And ta-da! So now let's go ahead and set the players to be in the center. stay 0. That will set those to be in the center of the screen as well. So that's a little too low. A little off, I would say here. Shouldn't be. Get size divided by 2 plus the height divided by 2. So what's the height on these guys? The height is 60. This is just an older Dell keyboard that I'm using right now, actually. It's nothing too special. Yeah. Okay, that'll work for now. And then I'm going to come over to the ball, and we also want to give this control over the score objects. So what we'll do is we will say score 1, score 2. And then these are as well going to be given an initialization. There. I always hate doing this, but render, window, window. There's that. The main game. Window. that, we'll go ahead and increment that score. And that should go ahead and increment the other score. Yep. Finally, we need to set the scores to be on the appropriate sides. Side position, and then window, size, minus this, score 2, get over bounds dot over 2. That's a little too much. Oops. So I don't want to do that. And of course we could set the colors to be different too. And the scores on the wrong side. Score 2, score 1. We need to make that a little less sensitive for player 1. Let's say minus 10 pixels. And that will let us be able to actually get the ball back over. And make sure we get the right side of the ball and check whether it is greater than the window size minus that, plus 5, and then minus 5 there. Give a little bit of leeway, but not a whole lot. So now you have to be a little bit faster. And then we want to, of course, also set the ball's velocity to be reset, which is a simple matter of copying this. So what we're going to do now is, just to kind of clean things up, we're going to make a reset button. Reset. And this will take in a render window. And we'll come down here. This reset. We can actually just call that void ball reset. And set the position. In the window. So that'll reset that, it'll reset the velocities, and then we can also even have it reset the paddles. So we'll come here, grab that, and that will reset that. And that's already being done there, so now we just do this, object, reset, and we pass in the window. And that'll go through and create our full game. And so now when that happens, our paddles will be reset and we'll be able to continue on.